Hello guys, am I audible? I'm sorry for the delay. No, I did not forget the stream. Is everything fine with my video and audio? Awesome. Awesome. Yeah, sure. I will do that. Well, first of all, okay, let's start the stream now. I think we are already late. Guys, today we're gonna have a topic stream about dynamic programming, and because this is the first one for now, we have to cover basics as well a little bit, but this is not the only thing we're gonna do. As you can see in the descriptions of the video, first of all, we're gonna start with basics of dynamic programming, the logic behind it, and when to apply it, because that's a very important thing. This is important both in easy problems and harder problems, to know how to apply dynamic programming. And then we're gonna solve some CF problems, starting from a CF problem with difficulty 1500, then 1700, then 2000, 2200, and 2300. We're gonna solve 5 CF problems. So there are 6 things that we're gonna discuss. I will try to cover all of them. Let me pause the video when I'm here. I'm trying to interact with you in the chat, so whatever you wanted to say, you can say that in the chat and I will respond it, but I try to limit my responses to in between the explanations, so that all the explanations will be straight, and only between them we will have some time that we can discuss, and you can ask me questions and I will answer them. I expect every part to take around 50 minutes in average, and then for each part we're gonna have 5 minutes of time for discussion and Q&A, and in total the live stream is expected to be for 2 hours. And if what we said was not enough and you still had questions, since we need to move on to the next problem after around 5 minutes of Q&A, I will answer the rest of your questions in the Telegram channel. So let me send you the link of the Telegram channel. I will answer the rest of the questions in this Telegram channel, so feel free to join and we will do the further discussion, etc. there. Okay, shall we start? Yes, I plan to make this a series of various topics. Yes. You are a newbie? Yes, you can attend. This is designed in a way that without any prior knowledge you will be able to understand what it is. And even the ones who have higher ratings, maybe at the beginning it might sound a bit boring for them, because we're gonna start with covering the basics, etc. But we will try to go to more advanced topics and solve harder problems faster. But yeah, be sure that I tried to design it in a way that it would be nice for people of different rates. First of all, it doesn't need any background knowledge, so everybody can attend. But at the same time, for it also has problems, it's harder difficulties, so that it would be good for people with higher ratings as well. So okay, let's start. We are a bit we need to go a bit faster because we have already lost 15 minutes. So, and guys, if you are right now watching this video, I mean, if you're not watching attending the live stream, but you are watching the recorded version, that is nice, and I hope that you use it. But it would be better, I think, if from the next one you can also attend the live stream, so that we can also interact with each other and talk with each other during the live stream, and we can go into more details together. And guys, also I would love to have your thoughts, so feel free to comment in here or in Telegram, or send me a message. Any suggestions that you might have after this stream, any suggestions on how to improve. So let's get started. Let's start about what is it. This is the first part that I'm gonna talk about, the basics of dynamic programming. And guys, as I said, maybe during the explanation I cannot read your chats, so that's we can have a very straight explanation, and in between them I will try to answer your questions and your comments. But feel free to write anything you want. If you had anything to say, I will read them in between the explanations. So let's talk about the basics of dynamic programming. So the question is that, what is that? So this is something that the most of you know, but the more important question is that how to figure out if we can apply that. How to figure out if we can apply that. So the best way to start talking about it is to start with a example that shows that what is the point that we're gonna, what is the main point of doing this dynamic programming. Well, guys, the general idea, the general concept behind dynamic programming is that we have a problem. We have a problem that we want to solve, but we will define several sub-problems. So we have one problem, one main problem. The way that we're gonna approach it is to define several sub-problems and solve such that those sub-problems, their answers are gonna help each other to be calculated. So when you want to calculate the answer of a sub-problem, it will use the answers to the other sub-problems, other smaller sub-problems that you solved already, and you're gonna use them to calculate the answer of this specific sub-problem. So we started with just one main problem. From this one main problem, you made many different sub-problems, for example, n sub-problems or anything. And just a variable, I mean, it can be anything. Okay, any sub-problem. And this is your responsibility to find out how to define sub-problems in a way that it really helps. In a way that it helps. We're gonna go through several examples so that you can really see that what do I mean, what are the ways to define the sub-problems, and why those are going to help in the problems. So the only question is that how to define these sub-problems. And the main point is that why we do this. I mean, instead of only one problem, we are making our own responsibility to not just only answer that problem, but we are defining so many problems, and we say that, okay, let's solve all of these problems. One of them is your original problem. So you define n sub-problems instead of the only one problem you had, and you said that, okay, instead of just solving this one problem, let's solve all of these problems. So why someone should do that? Why you are making our work harder? We are saying that instead of solving that one problem, let's solve all these n problems. Why someone should do that? And how can that be useful? Right now we are at the basics. So let me again show you this plan. This is our plan, and we are at step 1 right now. So the point is that the best way is to take a look at an example, a famous example. That's if you have watched any dynamic programming videos or topic streams or attended any classes, this is the first example that everybody say. And what is that example? Can you predict what that example is going to be? There is one example of dynamic programming that's in almost everywhere. This is the first example that people say. Yes, most of you are correct. Fibonacci. Fibonacci is something that every time that someone wants to start talking about dynamic programming, they will start talking about Fibonacci. Why? Because it's a very simple example of it, that you can see how defining so many sub-problems is gonna help you. So the Fibonacci sequence is a sequence like this. It's like f of 0, f of 1, f of 2, and so on. And it goes forever. So there's no limit for that. This is an infinite sequence. F of 0, f of 1, 2, and so on, f of 2, and so on. So the values of Fibonacci sequence are this. F of 0 and f of 1 are equal. F of 0 is equal to 1. Sorry, f of 0 is equal to 0. F of 1 is equal to 1. And for I greater than or equal to 2, f of I is equal to f of I minus 1 plus f of I minus 2. Okay. So the point is that in here, assume that, so if I write the first few elements of Fibonacci sequence, it's going to like this: 0, 1, 1, 2, 3, 5, 8, 13, and so on. So now assume that you are given a value n, which can be up to 10 to the 5th, and you have to say what is the value of f of n modulo some value, modulo some mod. Because this value is too huge, most of times in problems they do not ask you to print a number that is too huge, because it will overflow. It cannot fit into int or long or anything. So you have to just say that what is its modulo some value mod. And mod is just most of times is a prime number, like 10 to the power of 9 plus 7 or other prime numbers. So the point is that, okay, I am supposed to, sorry, I am supposed to find f of n. But as you can say, in order to find f of n, in order to find each f of I, the values of f of I minus 1 and f minus 2 are gonna help. So the point is that if I say that, okay, let's forget about just calculating f of n, let's calculate all these values. All these values. So this is an example that instead of one value, I make my own work like harder and say that, okay, let's just, instead of just find value of f of n, let's find f of 0, f of 1, f of 2, 2, f of n, all of this. So I defined like n plus 1 subproblems that I say that, okay, let's find all of this instead of just find f of n. So it looks like I just made my own work harder. And why did I do that? That doesn't make sense in the first look. But why did I do that? The point is that the answers to these subproblems are gonna help the other subproblems to be calculated. So these subproblems, it's like they are different parts of a great system that I have, and each of these parts are gonna help the other parts to be done as well. So it's like I have a place that I'm gonna calculate n plus 1 values, and I know that all these values, it's like it looks like they are going to help each other to be calculated. So the point is that, for example, I simply know that if I know f of I minus 1 and I know f of I minus 2, then I can simply find out what is f of I. So the point is that, okay, let's solve all of this. Let's keep all of these values. And let's assume that I need to find all of these values, not only the value of f of n. By doing that, I can just have a code like this. I can say that f of 0 is equal to 0, f of 1 is equal to 1, and then I can have a for I equal to int I equal to 0, int I equal to 2, I less than or equal to n I plus plus. And then inside it, I can just say that f of I is equal to f of I minus 1, sorry, it's an array, plus f of I minus 2 f of I minus 2 modulo mod. And this way, at the end, I can just see out f of n, because that's the only thing that user wants. The user just cares about f of n. But what I did was to calculate all the values from f of 0 to f of n. Because I believe that by calculating all these values are going to help each other a lot. So if we want to ask, that's how to find out if we can apply dp, if we can apply dp, how to find that out. Well, the point is that you need to see if in this problem that you define, is it easy to find several subproblems or like several instances of the same problem. These problems are like several instances of the same problem. For example, all of these problems, f of 0, f of 1 to f of n, they are all the same problem, calculating the Fibonacci number, but there are just several instances of them. One of them is for I equal to 0, one of them is for I equal to 1, etc. So the point is that if you can define several instances of the same problem, that these instances are gonna help each other to calculate, to be calculated. So each of these values is gonna be helped by the others that we are calculating. And we are gonna go through it and see that how it's gonna be understandable. How can we find out if we can really do that? I mean, how can we find out all those states? And in dynamic programming, there are several steps that are important. One thing that we have in dynamic programming is the base cases, which in this case of Fibonacci is f of 0 and f of 1. The values that we fix at the beginning, they are the base cases. And this is the one of the things, and the other ones, the other values will be updated. The other values will be updated by the previous values. Like for example, for 0 and 1 we said that what is their value. For the other ones we just said that okay, calculate that using the previous ones. If you have watched my videos on DP previously, I defined 4 steps for calculating DP. Can you say that what those 4 steps are? Does anyone already know that? What were those 4 steps to calculate DP? I defined a 4-step way for calculating DP. Yeah, okay. Let me show you chats. Yeah, you are close. But let me say this to you. The 4 steps are like this. The 4 steps of DP. The 4 steps of DP. The first one is to find out the states or the subproblems. We also call them states, and you will see that why they can also be called the states. Find out the states or subproblems. Define base cases. So first let's find out that what are our base cases, and then find transitions. Transitions are the formulas to calculate DPs based on the previous values of DPs, and at the end print the final answer. In the Fibonacci example, find out the subproblems was where we decided to calculate all the values from f of 0 to f of n. Define base cases was when we decided to set f of 0 equal to 0, f of 1 equal to 1. Here, and transition part was here that we said that f of I is equal to f of I minus 1 plus f of I minus 2, and this was the last part when we see out f of n, what user wants. Okay, so we have to, based on our timeline, we have to now move on to start discussing problems. Do you have, first let's talk a little bit and see if you are completely okay with everything we discussed so far. Do you have any questions from any part, or shall we start talking about the first problem? This is the first problem that we're gonna do. No, let me find. The first problem is the problem A. This is one of the problems that we're gonna discuss later. I'll show you this. Let me bring the first problem. Okay, So let's start talking about the problems. We're gonna solve 5 problems. So let's go through them now. The first problem that we're gonna discuss, I also sent the link of these problems here, so that if you want, you can also read them by yourself, but I'm gonna also explain it. Well, this problem says that we have an array of numbers. Each time we can choose one of these numbers. For example, we can choose these 2, and then our score will be increased by 2, but all the values, if the number we choose is x, all x minus 1s and x plus 1s will be removed from our array. So each time we can choose some element a sub k, and after that all the elements equal to ak plus 1 and a sub k minus 1 must be deleted from the sequence. But the point is that when you delete a sub k, your score will be increased by a sub k. Let me explain this further on tablets. So we have some array like this. Let's say it's like 1 4 3 3 2 4 1 3 4. This is our array that we have. Each time we can choose one of the elements. For example, I can choose this 3. Then my score is initially 0. When I choose this 3 and I delete it, my score will be increased by 3. But at the same time, other than this 3 itself, all the elements equal to this value minus 1, which is 2 in this case, and this value plus 1, which is 4 in this case, all of those will be deleted from our array. So the next time we have to choose again from the remaining numbers. So all the 2s and 4s are removed. For example, the next time I can choose this 1. Then our score will be 4. And all the 2s will be removed as well. All the 2s and all the 2s will be removed as well. There is no 0. All the numbers, all the AIs are between 1 and 10 to the 5th. And also n is up to 10 to the 5th. Then the next time I can use these 3. And this one doesn't also delete anything. Our score becomes 7. Then we can delete this 1. It becomes 8. Then we can delete this 3 and it becomes 11. Okay, so this is the problem statement for the first problem. We want to find out the maximum score that we can get. Okay, we want to define the maximum score that we can get. So when I want to solve this problem, is the statement clear? Is anyone have any specific difficulty with this problem? And as I said, the link is here. So if you are okay with that, please use, for example, this emoji or put a plus. If you didn't, put a minus or tell me that you didn't. I want to see that what is the situation of the majority. If most of the people understood, maybe the rest of you can watch that part of the video. You can easily watch the specific parts of the video here. Because, so that's the time for the others won't be wasted. If the most of you didn't understand, I'll explain it again. So, just because one of you said that didn't understand, I very quickly have a recap, very quickly, just this time. I'm just saying that each time you can choose a number, remove that. For example, if you remove x, your score will be increased by x, all the x minus 1 and all the x plus 1 will be removed from your array as well. You want to make your score maximum. So, let's start thinking about this problem. Let's simulate the way that we can we have encountered this problem and we want to solve it. What you can say? Well, the first thing that captures my eye is this fact that a sub I is up to 10 to the 5th. This is not very normal. This does not happen all the time. So this gets me into thinking that maybe our solution can be somehow related to this bound on a sub i's. Okay, so the question is that I want to use numbers from 1 to 10 to the 5th, and I want to make the maximum score. So now I can say that let's not only solve this problem, but instead let's solve so many subproblems that look like this problem, but they're a bit different. Can anyone suggest that how can we define our subproblems? You know, the point is that you see several numbers in here. You want to use all the numbers from 1 to 10 to the 5th to make your score maximum. Maybe we can play with these numbers. When we seeing this, it gives us feeling to maybe like play with these numbers and define several subproblems instead of only one. Okay, does anyone has any idea? Awesome. Yes, this is a very good suggestion. A state could be maximum score when my maximum element is I. This is also another subproblem. This is also, so there are two subproblems that comes to our minds. We know that in the original problem we are going to use a sub 1 to a sub n, but also we know that we use numbers from 1 to 10 to the 5th. So we know that our numbers, our indices are from 1 to n, and the numbers themselves are from 1 to 10 to the 5th. So one thing that comes to mind is to define dp of I to be the answer if you only use the first I elements of dp. This is one thing that comes to our mind, one of the subproblems, but it seems like it does not help a lot because the values themselves in this problem look more important. Because when you remove a sub I minus 1 and a sub I plus 1 will be removed. And also, we know this strange limit for a sub I. So maybe the author is telling us to use this somehow. It's sending us a signal to take care of these values. So the other thing that we can say is to define dp of I as this. That we will use only the numbers from 1 to I. So my subproblems are going to be this. dp of I is going to be the answer if we only consider the numbers from 1 to a sub I to, sorry, not a sub I, from 1 to I. So, and ignore every element greater than I. For example, in this example that we had in here, we had 1, 4, 3, 3, 2, 4, 1, 3, and 4. In here, for example, if I want to answer dp of 3, dp of 3 is gonna be the same problem. The only difference is that it's like I remove all the 4s. I do not consider them. I only consider all the numbers from 1 to 3. Also, in dp of 2, I do not even consider the values of 3s. I only consider 1 and 2s. So dp of I in general says that only consider all the numbers between 1 to I. Ignore all the other elements. Assume that they are already removed. Okay. So how does it help if we define our dp like this? Well, the point is that if you define this DP like this and start from the beginning and calculate the DPs, something like this will be happen. First of all, it's easy to calculate the base cases with this definition. So we're done with define. This was the first part. Defining the subproblems. We're done with this part. So the second part is to find or calculate the base cases. Can anyone help with the base cases? What do you think is good for the base cases? Do you have any suggestion for the base cases? For the smallest I, dp sub I is equal to CNTI. Yes, these are good ideas. Yeah. And let me first explain to everyone that what CNT means in your explanations. From the point of view of people who send solutions in chat, CNT of I is defined. Let's assume that CNT of I means that how many I's do we have? How many I's do we have? For example, in this example, CNT of 1 is 2. CNT of 1 is 2. Because we have 2 2's, CNT of 2 is 1. This is easy to say that for each AI that we get, we just say that CNT of AI plus plus. CNT of A sub I plus plus. CNT of 3 is 3. CNT of 4 is also 3. This must have been removed at the beginning. Okay, so these are the values of, oh, it's beyond my picture, sorry. CNT of 1 is 2, and 2 is 1, 3 is 3, and 4 is 3. So what you're saying is that for 1, dp of 1 is gonna be CNT of 1, because we can just choose all the ones and there's no problem with that. Also, we can say that dp of 0 is equal to 0, because when we set I as 0, there's no number that can be in our array. So our array is empty, we cannot do anything. So dp of 0 is also 0. So these are our base cases. dp of 0 is 0, dp of 1 is CNT of 1. Now let's find out the transitions. Now let's talk about the first part, the third part. Find out the transitions. So we want to find out dp of I for I greater than or equal to 2. Well, the point is that there are two cases. I can either use I or do not use I. There are these two cases. Either I will use I, or in other words, I will keep I will keep all the I's and I'll increase my score by them, or no, I will not use them. For example, maybe because I'm gonna use I minus 1, because I know that I cannot use I and I minus 1 at the same time. Because the first time that you pick an I minus 1, all the I's are gone. The first time that you pick an I, all the I minus 1's are gone. So you cannot use both at the same time. You can only use one of them. So maybe you want to use I minus 1 and therefore you will not use I. Can you say that then what the answer is gonna be if you do not use I? If you do not use I, you can just say that dp of I is gonna be equal to, the answer that you're gonna have, exactly, you're right, is gonna be dp of I minus 1 if you're not gonna use I. But if you will use I, the point is that if you use I, you know that all I minus 1's are gone after that. So now you're gonna use i's and there's CNT of i's. So you will add CNT of i's because you will use them, and then I minus 1 will be removed. When you use the first one of them, all the I minus 1s are removed. So these i's are not in danger anymore, and they will be there. And you can then pick them one by one whenever you want. So at the end you will pick all of them. So you're gonna have CNT of I times I plus, now I minus 1 is gone. And now in our new problem, all the numbers are from 1 to I minus 2. So it's like CNT of I times I plus dp of I minus 2. So these are the two cases, and therefore we can say that dp of I is equal to maximum, because we need to see that what is the maximum of these two cases. Is it better to not use I or using I? dp of I is going to be maximum of dp of I minus 1 is if we do not use I, and CNT sub I times dp of I plus dp of I minus 2. CNT sub I times I, sorry, not times dp of I. CNT sub I times I plus dp of I minus 2. Because you're gonna use CNT of i's and then add dp of I minus 2. And yes, as you can see, most of you have predicted that as well. And yes, these values that you say are all correct. Exactly. Okay. So let's talk about this one. Is this problem also okay? Did you understand it well? Or do you have any questions? If you have any questions, you can now ask questions. If you're completely okay with that, you can use this emoji again. Awesome, thank you. Yes, I can also show you implementation. I can use my own implementation. I implemented in 2015. So I was a kid back then, so maybe the code will not be in the cleanest form. But you can see that I have these AIs, and I just B of AI shows that how many AIs do we have. And then I say that initially, as you said, ans of 1 equal to B1. As you said, I didn't, and ans of 0 is already 0, because by default it is 0. You do not need to set this. And then I have a for I from 2 to 10 to the 5th. This is not very clean way of coding, but this code is from 2015. So I was 10 years younger than today now. So ans of I is equal to maximum of ans of I minus 1 and ans of I minus 2 plus I times B sub I. This is the exact same thing that we talked about in tablet. dp of I is equal to dp of I minus 1 and CNT of I times I plus dp of I minus 2. So the point is that in this problem we saw that we can easily define so many sub-problems like this. We can just say that just let's consider all the numbers from 1 to I instead of using all, considering all the numbers. And these subproblems are going to help a lot, because you can have two cases on using or not using the maximum number, and then you will go to two different DPs, and one of them is dp of I minus 1, one of them is dp of I minus 2, and you're going to add all the values of i's to the end of. Why dp times I? I'm not sure what you're talking about. Yeah, dp of I minus 2 parts was saying that assume that I will pick i's, assume that I will use i's. When I use i's, all the I minus 1s will be removed. So how many i's do I have? How many i's do I have? I have CNT of i's, right? So the score that I will get is CNT of I times I. And then after that, all the I minus ones are removed. So then, by getting all these I's, and all the I minus ones get removed, now our maximum, because all the I's and I minus ones are gone now our maximum is I minus 2. That's why we will use dp of I minus 2 afterwards. So in this case, we will use all the i's and all the I minus ones will be removed. So now it's like we will move to the instance of the problem that our maximum is I minus 2. So this is how I'm using the intuition behind the fact that there must be a reason that a sub i's are up to 10 to the 5th. I'm just saying that, okay, let's just consider all the numbers from 1 to I for each I from 1 to 10 to the 5th, from 0 to 10 to the 5th. So the point is that when I consider it like this, I can just have two cases on the maximum, and based on that, I can go to two different dp's. If the maximum is I can go to dp of I minus 1 if I don't use I at all, and I can go to dp of I minus 2 plus CNT of I times I if I use I, and then I minus 1 will be removed automatically and I will go to that. So it's like, again, I have defined some sub-problems that they're gonna help each other a lot to be calculated. That's why my sub-problems were good, and now I can easily calculate all of them, and my final dp of 10 to the 5th is gonna be my final answer, because in the main problem, I can use all the numbers from 1 to 10 to the 5th. These values are just helping me to calculate the final value, the final sub-problem. Okay, so these values, these intermediate values are just gonna help to calculate this final answer, this final dp. Yeah, I think in 2015 I was 15 years old. So yeah, so I don't know which grade is that gonna be, 9th or 10th. I started CP 10 years ago. Okay, yes, as you can see in here, I started dp. I have 2 messages. I try to respond them after the video, after the live stream. I started CP 10 years ago, and guys, because we need to move on to the next problems after around 5 minutes or around that in our live streams, you can always use this Telegram address, and let's discuss further in this Telegram channel. So for now, let's move on to the next problem. If you had more questions, etc., let's talk about them in the Telegram channel. So let me first bring the next problem in here in my laptop. Okay, so let's move on to the next problem. 977F consecutive 977F consecutive elements. Okay, so consecutive subsequence. So this problem is saying that you are given an array integer of length n. You want to find some subsequence of it such that they are consecutive numbers. For example, if your sequence is this 3, 3, 4, 7, 5, 6, 8, you have a subsequence of length 4 by choosing the second element, the third element, the fifth element, and the sixth element. You're gonna have 3, 4, 5, 6. So it's like you have a subsequence, and the subsequence is just if we choose a subset of the elements. By removing some of the elements, we can reach to a subsequence. For example, if here we remove this 3, this 7, and this 8, we're gonna be left with 3, 4, 5, 6, and they are gonna be consecutive integers. So we have an array, we want to find the maximum size of a subsequence of consecutive integers. In this example, we can choose 1 and 4, the first and the fourth element, digit 1 and 2. In this one, the answer is 1. In this answer, we can choose the first one, the second one, the third one. and the 7th one, the 8th one, and the 9th one. Then we have 6, 7, 8, 9, 10, 11. So is the statement clear? It is not LIS, because LIS needs to be in increasing order, but in here we need to have consecutive increasing numbers. So they should be right after each other. They must be consecutive, but in LIS they do not really need to be consecutive. If you are okay with this statement, please again use this emoji. Yeah. Yes. So we have this sequence. Let's write an example for it. Let's just choose this first example: 3, 3, 4, 7, 5, 6, 8. So we want to find out the greatest subsequence with consecutive increasing numbers. Okay. Let's define again some subproblems. I know that any of these consecutive subsequences are gonna end at somewhere. Okay. So I can say that all these subsequences are gonna end at some place, right? So why not choosing these as our subproblem, these cases as our subproblems? So we know that any of the, for example, you know, in general, we do not care that where the subsequence ends, but we can have different cases for that. Either our our consecutive subsequence ends here, which the maximum length for that is 1. We can only choose these 3. Or it ends here, then the maximum length again is 1, because again we can choose only 1, 3. Or it ends here, then our maximum is 2, because you can use 3 and 4. Or here, which the answer is gonna be again 1, because we cannot use 7 with anything else. Or here, which is gonna be 3, we can use 3, 4, 5. Here we can use 3, 4, 5, 6, so it's gonna be 4. And here it's gonna be 2, because we can use 7 and 8. So for each I, so here, the intuition that I'm gonna have after reading this problem is that, okay, what are the cases that I can consider? Okay, this problem looks like maybe I can define several subproblems and try to solve them independently, solve them such that they will depend on each other, such that they can use each other. So the point is that if I define, because all the elements should be consecutive, if I go from left to right, each element should be 1 more than its previous elements. So if I go from left to right and calculate dpls of i's, then the previous dp's can help us. So the first guess that I might have is this: dp of I is the longest subsequence with consecutive numbers ends at position I. That ends at position I. So this is the first thing that comes to my mind. I will try to find the longest subsequence ends at position I with consecutive numbers. But do you have any better idea? Maybe there's something that is even better than this. Exactly, awesome. This idea even makes things simpler. We use dp of I, the largest subsequence, the longest subsequence that ends with integer I. Here we know that a sub i's are up to 10 to the 9th, which is a lot, but still we can do something with it. So for a second, let's assume that all the numbers are up to 2 times 10 to the 5th. So we know that n is up to 2 times 10 to the 5th. And let's first assume that ai's are also up to 2 times 10 to the 5th first. Okay, let's first think this way. Then we can define dp of I, dp sub I, as the largest one that ends with integer I. So this way, we have all these numbers, we have defined all these dp's, and then our base cases can be starting with all dp's being 0. So as our base case, we start with the fact that, okay, all the dp's are 0 at the beginning. This is gonna be our base case. Now how can we translate and find all the numbers? How can we find all the values? Well, I can say that let's start from the beginning. And you know, we know that we first seen, I'm gonna talk about transition. First, we've seen the values of n. In this problem, we have another way of updating the values of dp's. I'm not gonna just have a 4 on all the dp's and calculate them based on the previous dp's. I might update the same dp several times, and you will see how. I can just say that for int of I equal to 0, I less than n, I plus plus, I will have several values for ai's, right? So I should see in I should see in a sub I, and then I can just simply say that dp of, I can just simply say that dp of a sub I will be equal to maximum of its current value, because it is currently something. It is maximum of dp of a sub I, whatever it already is. And do not forget that I have temporarily presumed that ai's are up to 2 times 10 to the 5th. Is equal to maximum of this dp and dp of a sub I minus 1 plus 1. And guys, I just remembered something. My stream is not shown on YouTube right now because we started late. I just realized it. And now it's up again. Okay, so dp of a sub I is equal to maximum of dp of a sub I and dp of a sub I minus 1 plus 1. What does that mean? It means that you want the last element of your alias to be a sub I. There are two cases. Either, for example, assume that a sub I here is 5. Okay, you'll want the last number of your subsequence to be 5. There are two cases. Either that last 5 is this 5, or it's one of those previous 5s that you have had already. If this is the previous 5s, not this one, then you can use the current value of dp of ai. Okay, then you can use the current value of dp of a sub I, because dp of 5 is something already, and then nothing changed. This element has no effect then. But if you will use this 5, you know that before that you're gonna need to use a 4. Okay, if there is some element, you're gonna use a 4. So the maximum length that you can have before is gonna be dp of 4. And do not forget that dp of 4 can also be 0. It means that we do not even have any 4. And dp of 4 can be 0 as well, that's okay. So this way the length of the LIS will be dp of 4 plus 1, dp of a sub I minus 1 plus 1. So the point is that dp of a sub I is going to be equal to maximum of whatever it is already if we do not use this last number. But if you're going to use this new a sub I, we're going to need to find dp of a sub I minus 1 before this. And that's going to tell you that what is the maximum length of an LIS that ends here. Is it clear so far? Do we have to do the max part? I not kinda just be max itself? Would I not? You know, this way is easier to explain, but you can also say that you can get rid of this part, and you can only say that dp of a sub I, you can, I wanted to start with talking this way, but you could also say that dp of a sub I is simply equal to dp of a sub I minus 1 plus 1. You could also just say this and forget about this maximum. Why? Because it's not hard to show that this 5, if my sequence is gonna end with the 5, this 5 is the best one to end with. Because if we have another 5 here that gives another subsequence to us, the point is that this 5 can be used there as well. So even if this 5 is used in the best increasing subsequence, consecutive increasing subsequence, this 5 could be used there as well. So it is never optimal. It is never better. So it is using this new 5 is as good as using the previous 5s at least. So it is not more optimal to ignore these elements. Okay, using this element is at least as good as not using it. So the maximum of these two values is always this value. And you could also say that dp of a sub I is equal to dp of a sub I minus 1 plus 1. So this way you can calculate all the dp's. Oh my god, why am... Sorry for that. So, yes, I wrote a lot of things. I was just saying that the maximum of these two values is always this value. Because it's always more optimal to use this number. If there's another 5 in here, that we say that this 5 is better than this 5, the point is that you can ignore this 5 and use this 5 instead. I mean, this is at least as good as that. So it's never better, it's never more optimal to ignore this 5. 5 is an example for a sub I. A sub I can be anything. So I'm saying that it's never more optimal to use another 5 instead of this 5, right? Because if you use another one, you could easily, instead of that, replace that with this one. So dp of a sub I minus 1 plus 1 is always greater than or equal to dp of a sub I. So you could also say that dp of I is equal to dp of a sub I minus 1 plus 1. You can get rid of that maximum. That is also possible. Because the point is that it is not more optimal to ignore these elements. Using this element is at least as good as not using it. So we can always presume that in dp of a sub I we will use the last a sub I. Because the previous a sub i's are at most as good as that. Does this make sense? If it does make sense, awesome. You can also use this emoji or put a plus in the chat. So now the question is that, okay, but we used an array in here that goes up to 2 times 10 to the 5th. But AIs are up to 10 to the 9th. So what can we do then? We cannot define an array of length 10 to the power of 9. So what can we do? Exactly. Awesome. We will do this. We will use map. Well, maps are some arrays that can have any size. So we can view them like that. It's like a map of int and ints. I do not go into details, but it can map any ints to any ints. And the point is that we can use any large number. I mean, we can define a map like this and then call dp of 10 to the 9th, and that's gonna be okay. That's gonna be okay if we call dp of 10 to the 9th. The only point is, because the way that map will be stored in memory is different, the only difference is that its access is gonna be O of log n instead of O of 1. So anyway, you can just, instead of defining dp of some fixed value, if you just in here say that define a map of ints and ints of dp, then you're completely good with everything. And you have the best dps, and at the end you find that which x gives you the maximum dp of x is maximum, and you know that your subsequence will end with x. Then you can start from the end, go backwards, and whenever you saw x, just store that in a vector and just find the sequence itself greedily. Let me show you our code. No, this stream will be recorded. It will be stored. Yeah, don't worry about it. So let's talk about the code. You can see my code here. So we have this value of n. We see in AIs, and we said that dp of a sub I is equal to maximum of dp of a sub I and dp of a sub I minus 1 plus 1. And we take the maximum of these dp's. We say that if dp of a sub I was greater than n, so let me see that when I accepted this one, this is accepted in 2024, so it's very recent. Anyway, so dp of a sub I was greater than ans. I set ans equal to dp of a sub I, and then I set car to ai. Car means that what is the current element, what is the current last element that I'm looking for. Then I see out ans, I start from the end, go backwards. I said that if my array is last, and if the last element of my subsequence is gonna be some car, it's better for it to be the last car. It's at least as good as the others. So I go backward. The first time that I found out car, I push it back to my vector, and then I say car minus minus. For example, as soon as, let me go back to tablet. So in this example, I know that my maximum answer is 4. My car is gonna be 6. I'm gonna start from the end and go backward. Maybe I have some additional 6s and other values as well. Maybe there's an additional 6 here, an additional 5 here. So an additional 3 here. Okay, I'm just making the test more challenging. So I know that my answer is still 4 and my current value is 6. I start from the end, go backward. Whenever I found the first car, I push it back to vector. So I push back this index to vector, to my vector. And then I say car minus minus. Why? Because now I'm looking for a number 1 less than that. Now I'm looking for 5. And again, among all 5s, it's the best to choose the last one of them. So then this 5 will be chosen. And now I'm looking for 4. Then I go backward. I see this 3. I cannot choose this 3 because at this stage I'm looking for 4s. I see this 7. I cannot choose this 7 because I'm looking for a 4. I cannot choose this 6 because I'm looking for a 4. I see this 4 and I will choose it because I'm looking for 4, and it's the best to choose the last 4. It's still as good as the other 4s. And then my car becomes 3. Then I come here. I skipped the previous 3 because at that stage I was looking for 4. But here I'm looking for a 3 and I see a 3, so I choose this one. And I push it back to my vector. Now I'm looking for a 2. And I go forward and I will not find any 2 anymore. So I will not have any 2. So this way that subsequence that I want will be easily made. Okay. So what I'm doing in here is exactly this. I start from the end. I greedily, each time if I see AI equal to car, I just push it back to my vector and then I say car minus minus. Is it clear? We are, we used a lot of time for these problems, and I think we need to go a bit faster in order to solve at least, even if we do not reach, if we cannot solve the last problem in this stream, but at least solve these 2 problems. What if there was no 3 left of 4? What do you mean? What if there was? The point is that if you use the last 4 among all the 4s, there is more probability. Let me pause this while I'm talking. There's more probability that you're gonna find the next elements afterwards. So in this example, all I'm saying is that, I'm looking for 6, so let's get the last 6. Then I'm looking for 5, so let's get the last 5. Then I'm looking for 4, so let's get the last 4. Then I'm looking for 3, so let's get the last remaining 3. And this way, greedily, I will find them. Okay? So I hope it makes sense. So now we need to move on to the next problem. But again, I invite you, I understand that maybe it is not completely clear for all of you. Because I want to save the coherence of the live stream, I want to move on to the next problem so that I will be able to cover all the problems. But as I said, you can always use this Telegram address. This is also in the descriptions. You can use this Telegram address and join the Telegram channel, and there we can discuss more and I will answer your questions. I will definitely answer all your questions there. So any part of the video, even if you're watching the recorded version of the video, that is, you can ask, don't hesitate to ask all your questions there. I will try to answer all of them. So, and also if you like the video and want to support my work, I would appreciate it if you can like the video here in the YouTube, or subscribing to the channel, or writing comments below the video. I think these things will help for the promotion of the video so that more people will see and get help from this video. So if you wanted to support this work, you can do that. And in order to do that, it's just enough to come here and just click on this like. Thank you guys. So let's now move on to the next problem. Let me remove this like that I sent to myself because it is a bit lame. But anyway, let's move on to the next problem. The next problem is with difficulty 2000 as promised. Is this problem. Problem red-green towers. It says that assume there are all red and green blocks for construction of the red-green tower. It's like a tower that looks like a pyramid. The first row has only only each of the levels have different values of different number of blocks. The first one, the topmost one, has 1 block, the next one has 2 blocks, the next one has 3 blocks, and so on. And each level should use the same color. Each level should either be green blocks or red blocks. And you know that how many red blocks and how many green blocks you have. First, you want to find the maximum height h that your tower can have. You want to find the maximum possible h, which is the maximum height that your tower can have, and then find that in how many ways we can color that tower, that tower with maximum height. Okay, and we have to calculate it modulo 10 to the 9th plus 7. Two ways are different if there is a row such that their color are different. For example, these are two different ways. In both of them, we have 4 red colors, 4 red blocks, and 6 green blocks. One way is to use these 6 green blocks like this and have this row with 4 blocks, and one way is like this. We have 1 in here and 3 in here, and 2 and 4 green blocks in these 2 rows. So the point is that, so we know that our pyramid, if it has length h, we know that in the first level there is going to be only 1 block, the second one is going to be 2 blocks, and in the last one there's going to be h blocks. So in total, if my height is h, the number of blocks that I will need to construct that is going to be 1 plus 2 plus 3 plus 2h. Okay. So the first thing I say is that the maximum height, the maximum h, is gonna be the maximum h such that the sum from 1 to h is less than or equal to r plus g. I know that I have r red blocks and g green blocks. Let me send you the problem statement link in here as well. This is the link of the problem statement. So we have R red blocks and G green blocks. We want to make a pyramid, and each level can have the same color. All the blocks in the same level must have the same color. We want to find the maximum H for the height of the pyramid, and then say that how many ways do we have to color that pyramid. So first of all, I say that the maximum H is gonna be in this way. The maximum height that we can have is the maximum value H such that the sum from 1 to H is less than or equal to R plus G. Why? Because I need at least these many blocks. I mean, it doesn't make sense if R plus G is less than 1 to H. If that's the case, it is not possible because I do not have enough blocks to put there to form my pyramid. So I have R plus G blocks and I need these many blocks for a pyramid of height H. So this cannot be less than that. So this is necessary. This is also sufficient because you can have, you know, that assume that the number of blocks B, we define B as 1 plus 2 to H, sum of sigma of numbers from 1 to H. I say that for any R and G, I mean, it doesn't matter how many, what is your value of R, what is your value of G. For any value from 0 to B, for any value X from 0 to B, there exists a pyramid. There exists a pyramid with X red and B minus X green towers. So I say that for any pyramid of height H, such that it would have B blocks, B is equal to 1 to H, sum of 1 to H. Then for any X from 0 to B, there exists a pyramid with X red blocks and B minus X green blocks. Why? Because first of all, assume that all the blocks are red. So first of all, I show that there exists, or let's say that first I start I kind of use induction. I start with a tower with zero red blocks. Okay, I start with 0 red blocks. I say that, okay, I can set all of them to green. Now assume that there is a way to do this with I red blocks. And now I want to have the case that I'm gonna have I plus 1 red blocks. So let's assume that right now I have I red blocks and I is definitely less than B, so it means that there is still is at least one green block. And now I want to make I plus 1 red blocks. I say that let's consider the first row, because I is less than B, there exists at least one row with all green blocks. This is the first such row. So either it is the first total row, or if it is not the first one but the one in the middle, its previous row is red. We can simply just swap these two rows and make this one green and make this one red instead. By doing this, the number of red cells will be increased by 1, will be incremented by 1. So I'm saying that I prove that for any value of I prove that for any value of I from 0 to B, there exists a red-green tower with exactly X red and B minus X green blocks. Okay, this is what I have proved. I use induction because I said that I use induction and I said that there is a way for with 0 red blocks. I can make the whole grid green. And then I showed that if it is possible to have I red blocks and I is less than B, then it is also possible to have I plus 1 red blocks. How? Because I is less than B, there exists at least one row with all green blocks, and if you consider its previous row, either there is no previous row, or in other words, this row is the first row, or there is. If there was, just swap these two. If there was not, just make this one red. By doing this, the number of red blocks can be anything. So I said all this to show that the value of R and G does not really matter to find the maximum H. The only thing that matters is R plus G. When I want to calculate H, when I want to find out the maximum H. Because if there is a way to put these blocks, if the number of blocks is enough to form a pyramid of length H, of height H, we can deal with different values of R and G. We don't care about what is our bound for R and G then. If there is enough blocks to form this pyramid, we will form this pyramid. Okay, and it doesn't matter that what R and G is. Is it clear? Intended solution is of n times square root of n? No. The solution can work with better time complexity. You cannot have more levers than colors. Yes. If you mean the number of blocks, but if you mean by colors, you mean just we can have 2 levels? No, that's not the case, because each row has its own color, but the colors can be used in several rows. It's not like we will use each one of them in only one row. Okay. Is it clear then? If you have any questions, feel free to. Yes, blocks, yeah, right. The number of levers and, yeah, the sum of the numbers from 1 to the number of levers also cannot be greater than R plus G. Okay, awesome. If no one has question, then let's continue talking about it. So, this is gonna be the way that we will find the value of H. Now the question is that now we know H. We know H. And now we want to find out the number of ways for each I. Now our subproblems can be defined like this. Let's, for each I, again, I will search on how can I define some problems that's gonna be helpful. How can I categorize the cases, categorize the whole solution space into different cases? Well, the point is that in here my cases can be categorized by the number of red blocks they have or green blocks they have. They are the same. Red blocks and green blocks can be calculated from each other, so it doesn't matter which one you consider. So assume that I will fix how many red blocks I will use. Okay, CNT of I is gonna be the number of ways to fill this pyramid with heights from 1 to h such that I'm gonna have exactly I red blocks. Okay, so how can I update this? Yes, I will update the description of the video with the link of all of the problems. I will put them in the descriptions after the video. Yeah, exactly. dp of I is the number of ways of red green blocks of height. No, not height till I. dp of I is gonna tell me that's how many red blocks I'm gonna use. Okay, how many red blocks I'm gonna use in my grids. Okay, in my pyramids. So the point is that CNT of I is gonna be like that. To make things simpler, let me just define for now. Let me define a two-dimensional one. Maybe this makes things simpler to understand. Let's define this. This would be the best way to define all the subproblems, and it's very easy to understand. Let's make it two-dimensional. Let's say we have dp of I and j, which says that with r red blocks and g green blocks, these are the inputs, so these are fixed values. These are the inputs, so these are the fixed values, which are red blocks and g green blocks. How many ways do I have to have a pyramid with heights I and j red blocks Okay, this way I'm defining several subproblems, and instead of just trying to find out that what is the number of ways that for the fixed height h, how many ways that I have to have this specific number of red blocks, let's define this for all the possible values of I and j, which says that in total we have r red blocks and g green blocks, and we can only use these. These are the constant values. These are in our inputs. And then I say that how many ways do I have to have a pyramid with height I using these blocks such that it has j red blocks. So the point is that how can I update this? First of all, I'm done with definition. I'm done with the definition. So definition is now done. The second part is base cases. How can I use base cases? How can I define base cases? What do you think they can be? Yes, I'll send you. Maybe at the same time I can keep updating the descriptions of the video. I will send you all the I will put all the problems there. But at the same time I want you to tell me that what can be the base cases for our DP. DP is two-dimensional, so make sure that you define it as two-dimensional. DP of 0 and 0 is equal to 0, 1 and 0 equal to 1, and 0 and 1 equal to 1. I guess the last one is 1 and 1, but this is perfect. How can you calculate the height if r plus g is 10? If r plus g is 10, then the height is going to be 4. Because 1 plus 2 plus 3 plus 4 is 10. And it is the largest value. 4 is the largest value such that such that the sum of from 1 to 4 is less than or equal to 11. So that's going to be the case. And I will put the links here in the description. Can someone send me the link of these 3 problems? I can search for them, but if you can send them right in the chats, that would be helpful. Then I put them in the descriptions, because I'm in the middle of explaining and I don't want to surf to pages. So as you said, the base cases, thank you very much, Gengi. The base cases can be like this. dp of 0 and 0, as you said, can be defined as 1. Because when we have 0 and 0, there's only one way: do nothing. We have no blocks, no heights, so what we want to put? Nothing. How many ways do we have to do nothing? 1. We just do nothing. That is a very important thing in dynamic programming. Most of times people wonder why DPs of zeros are 1 in many problems. Because most of times, I mean, in those definitions, you have to just do nothing. How many ways are there to do nothing? There's one way to do nothing. Just do nothing. Okay, so that's the main point. And that's why in here dp of 0 and 0 is 1. So, because you do not need to put anything. There's one way to not put anything. And then we have, for example, dp of 1 and 0 equal to 1. Our height is 1 and we have no red cells, and dp of 1 and 1. Our height is 1 and we have 1 red cells equal to 1. So these can be our base cases. Right? So, awesome. So we're done with the base cases as well. So now the question is, how to do the transitions. Can anyone help about that? How can we do the transitions? dp of 0 and 1 is not possible. So your question is that dp of 0 and 1, dp of 0 and 1 is not possible, because if the height is 0, we will not use 1 red. The first one is height, the second one is the number of red cells. So this is not green and red. This is the height and the number of red cells, the number of red blocks. Yeah. So there are 3 problems. Have you sent the link? Okay, let me continue this for now. So now we want to calculate the transitions. How can we do that? Well, when you want to calculate dp of dp sub I sub j, yes, it helps if you send on Telegram as well. Thank you. And if it was hard, never mind. I will add them myself after explaining this problem. Thank you. Thank you anyway. So dp of I and j can be calculated like this. Either my last row is gonna be red or it's gonna be green. If my last row is gonna be green, what is gonna be my dp of I and j, from where it will be updated? If the last row is green, yeah, so dp of I and j that way will be updated from dp of I minus 1 and j. So it's like now I have a pyramid of height I minus 1 and the last row of it and the number of red ones are j. Because the last row in the pyramid with height I was green, so it has no effect on reds. So now in this part I'm looking for j reds. So it's like I need to find out the number of dp of I minus 1 and j. And for now I'm just ignoring this, that I'm gonna have r red blocks and g green blocks. I don't care about the limits for now. I will consider them at the end. I will consider these limits at the end. So for now I'm just saying that, okay, if I'll have the last row as green ones, it's gonna be dp of I minus 1 and j. If it is red ones, it's gonna be dp of I minus 1 and j minus I. Because the last row, this way, in this case, the last row is red. So when the last row is red, it means that we already have, when the last row is red, it just means that we already have I red cells. So in total we have j red cells, j red blocks. So in here we need to search for j minus I red blocks. So dp of I and j is going to be dp of I minus 1 and j plus dp of I minus 1 and j minus 1, j minus I. And this way we can calculate our dp. Simply say that dp sub I sub j is equal to dp of I minus 1 and j plus I minus 1 and j minus I. Is it clear? Awesome. So if I want to show you my code as well, this is my code, and I just do this. You know, this code is also from 2017. I just say that in here, first I calculate the value of h, and in the middle of calculating h, I'm just also calculating this CNT. CNT of I means that in how many ways we have R red cells. You do not need to implement it like this. You can implement like what I explained in tablets, and you can just say that at the end you can search for all the DPs of H and I's and say that if the number of red cells must be at most I. So you need to say if I was at most R and if the number of blocks is B is defined as 1 plus 2 plus 3 to H. So B, let's define B as H times H plus 1 divided by 2. This is the sum of 1 to H, right? So I must be at most R and B minus R, I must be at most G. If that was the case, we add to ans dp of H and I. So this way we can just calculate the answer at the end. And that's the same thing that I've done in my code. I calculated CNT. CNT of I means that I made my dp one-dimensional in the code that I've done at that time. I just say that if CNT of I means that how many ways do I have to use I red cells, and at the end I just say that I have a for I from 0 to R, and I check if also the number of green blocks were at most G as well, and plus equal to CNT sub I. But the point is that my only difference is that I will increase H as much as possible. So while H times H plus 1 divided by 2, I will increase H. And at the end, I just do H minus minus because I go far for one more additional step that we shouldn't do that. So at the end, because I'm gonna have one additional increment for H, I need this decrements as well, just one decrement. And then I go backward and just I say that CNT sub I plus equal to CNT sub I minus H, because now a new row is added. This new row is either red or it is green. If this new row is red, if this new row is green, this doesn't change anything. CNT of I remains whatever it is. So CNT of I is either CNT of I which it was before, or it will be added by CNT of I minus H, because if this new row is red, now I should look for I minus H additional reds previously. And the reason that I do this for backward is because when I want to update the value of CNT sub I should have not updated the CNT of I minus H before that, because I want it to still be for the previous heights so that I can update these values. Is it clear? If it is not, because we're a bit late and we need to move on to the next problem, again I ask you to ask your questions in Discord or Telegram channel. Telegram is better. I think I check Telegram channel more often. And the Discord server, we need to make some reconstruction in the Discord server very soon because it's very complex right now. It has many channels and we need to just make it more clean. So awesome, is this clear? Awesome. Yeah. Yes, exactly. Thank you for helping me in explaining this. And if you have had any additional questions, I'll ensure you that I will answer all. You can just here, as I said, come. You can come here and join the Telegram channel, and I'll put a message for discussion for this DP topic stream. And below that, you can ask all your questions or discuss further and talk about this live stream. And I'll try to make these live streams weekly at this time on Fridays, 12 to 14 GMT. And we will also decide there that what we want to be the topic of the next topic stream. For this one, the vote was for DP and for this time. And we will decide for the next ones as well there. So let me also talk about the next problem, the fifth problem. I think we cannot do the sixth problem. I had to leave at 14 GMT, which is in 10 minutes, but I think I cannot do that. I have a meeting after that. But I'll be late then, and I have to also skip the last task. But let's do our best and try to solve this next problem. The next problem is this one. Winter is here. Let me send you the link. Thank you very much. Thank you very much. Yes, so now the links of the problems are there also. Yes. Each week we're gonna have a live stream and we can decide. Obviously, these have more parts. This is the part 1 of the dynamic programming, and we will cover more parts, and we will go further definitely. So winter is here. This problem says that winter is here at the north, and you know, if you forget about this story, it's just saying that for each subset of numbers such that their GCD is greater than 1, we just add k. For example, we presume that they are k numbers. So for a subsequence of k numbers such that their GCD is greater than 1, we will add the value of the length of the subsequence, which is k, times the GCD of them. Your task is to find this value. For example, in here, these subsequences have GCD greater than 1. If you only pick this element, or you only pick this element, or you pick these two elements. In this case, GCD is 3. But if you use this 1, the GCD will turn into 1. In these cases, accordingly, your values will be 1 times 3, 1 times 3, and this one, because the size is 2, 2 times 3. And when you add them up, you're gonna get 12. And for this one, for example, maybe you can use this 2 and 4 as one subsequence, 2 and 6, 2 and 4 and 6, 3 and 6. And this way, and also each element alone, because all of them are greater than 1. So for any subsequence with length greater than 1, for any subsequence with GCD greater than 1, the length is not necessarily greater than 1. So let's write the subsequence itself as well. A sub I, A sub 1, A sub I sub 2, and A sub I sub k. GCD of them must be greater than 1. You will add value of k times this GCD. And you have to say that what is this value? Well, the first thing that I do on this problem, sorry for that, the first thing that I do in this problem is to find out for each x This can really help. This number is a bit like number theory as well. It's somehow like combination of number theory and dynamic programming. So if for each x I have some CNT of x, that tells me how many numbers are multiples of x in my array. So I have defined some CNT of x that says that how many elements are a multiple of x in my array. So how can that be calculated? Well, I know that my values of n, if I look at here, n is up to 2 times 10 to the 5th, and the values of ai's are up to 10 to the 6th. So these are the values that we have for n and ai's. And how can I calculate that how many elements are a multiples of x? I can just have a for. Whenever I get some value like ai, I can have a for up to its square root. I can have a for from 1 to the square root of a sub I, and I can just add, if a sub I was divisible by that, I will add 1 to the CNT of that number. Maybe it's better to show you my code here. I'm not gonna jump into solution, but this is the first thing that we want to calculate when we see such a problem, because we want our GCD to be something. We need to know that how many ways do we have so that our GCD will be that number. Okay, so for each x, if I want to find out that in how many ways my GCD is going to be x, I need to find out that how many numbers are divisible by x first. Because when my GCD is x, all those numbers that I've chosen are divisible by x. So I need to find out that how many numbers do I have such that they're all divisible by x. Yes, whenever I get some AI, I want to, my goal, whenever I get some AI, my goal is to increment the CNT of all its divisors. And how do I do that with a good time complexity? For this part, I just, when I see in some elements, I just have a for y from 1 and until y times y is less than or equal to x, and I increment y by 1. If x modulo y was 0, or in other words, x was if x was divisible by y, I will increase CNT of y by 1, and then I say that if y times y was not equal to x, it means that y was not equal to a square root of x, or in other words, x divided by y was not equal to y. Then also increase CNT of x over y. This if is because if y and x over y are the same, if y squared is equal to x, then y and x over y are the same. So the CNT of y will be increased twice, which doesn't make sense. So we need to make sure that all the divisors will be increased by 1. So only in case that x over y was different to y, I should also increment x over y. This way, all the divisors of x, their value of their CNT will be incremented. And at the end, I will have the CNT of all the numbers, which means that how many numbers are a multiple of this number. So at the end of this step, I'm gonna have CNT of x that says that how many numbers do I have such that they are all multiples of x. So now, if I want my GCD to be some x, I need to choose numbers from these elements. There is only one issue here. Can anyone say that what is going to be the issue that I might have here? I mean, if I only choose some elements out of the CNT sub x elements, there might be one issue. Maybe their maybe their GCD will not be x. Can anyone say why? What do you mean by overlap? The link of the Telegram is pinned here. You can find it here. But I'll send it again anyway. So, yes, very nice. So, yes, thank you. So the point is that if all the numbers, if a sub I sub 1 and to a sub I sub k, they are all divisible by x, maybe they are also divisible by 2x, then the GCD is not x, GCD is 2x then. Or maybe they are all divisible by 20x, then the GCD will be 20x, not x. So the point is that just having x is not enough such that the GCD will be x. By all of them having x, we just make sure that they are divisible by x, but we are not making sure that x is their greatest common divisor. Not only their common divisor, but their greatest common divisor. So the point is that initially I set res of x. So I want res of x, or let's say dp of x, to clarify that here is where we want to use dp. I want to find out, I want to use dp, my idea is this, I want to use dp in order to find out in how many ways my GCD is x. My GCD is x for each x. So dp of x, dp sub x says that how many ways do I have such that my GCD is x. So how can I calculate that? First of all, I can set dp of x to be, for a second I can forget about the issue that we mentioned. About the issue that we only consider all the cases that x is a common divisor of the numbers. Not their greatest common divisor, but only their common divisor. Then those numbers are gonna be 2 to the power of cnt of x, because each of those elements can come or not. I mean, we have cnt of x numbers all divisible by x. I can choose either one or avoid choosing either one. So this is gonna be my dp sub x. It's gonna be equal to 2 to the power of cnt of x initially. There is just one that I should subtract. I should only subtract 1 because there's only one way that I choose an empty subset. I will not choose any of them. So initially I set dp of x equal to this. So right now x means that in how many ways I can choose numbers such that they are all divisible by x. X is their common divisor. So this is how I can first calculate the number of them. Let me first explain more, and then we will move on to the final answer. So, do you have any questions so far? Exactly, yes. We need to make sure that all the x is the greatest common divisor that they might have, and not only their divisor. Okay. So if everything is so far and clear, so far everything is clear so far, please. This -1 that we're talking about is in order to make sure that we do not choose an empty subsequence. Because we say that for each one of these values, there are 2 ways. Either we will use them or we will not use them. Right? So the point is that if we will not use any of them, then we will have an empty subsequence, but that doesn't have any GCD or anything, and that is not going to be helpful. Okay, so this way you're gonna have the number of ways that to choose some elements such that their common divisor is x. X is a common divisor for them, but it's not necessarily the greatest common divisor. What I do next is this. I'll have a for starting from the greatest x, starting for ints x equal to n minus 1, x greater than, this is my max n, not my max n, my max a, let's say, my maximum number, which is, for example, 10 to the power of 6 plus 20. This is a constant int that I use. And if it's better if I explain it this way, let's say a is 10 to the power of 6. I start from a, I go till it is greater than 0, and x minus minus. I'll do this. I'll have a for int y equal to 2 times x, and y less than or equal to a, y plus equal to x, and I just say dp of x minus equal to dp of y. Why do I do this? Well, the point is that I know that right now my dp of x means that all the numbers are divisible by x, but I want to make sure that x is the greatest common divisor. So I want to change the definition of dp from x being a common divisor to x being a greatest common divisor. The point is that if you consider the maximum number for a, for capital A, which is our maximum number, the point is that if this number is a divisor of all the numbers, then it definitely is the greatest common divisor as well. So if I start from the end, it's like I want to go on all the numbers and one by one make sure to change their values, change their definition from x being a common divisor to x being the greatest common divisor. The point is that if I go from the end, go backwards, when I'm on x, I'm sure that I've done this change for x plus 1 to a. So I'm sure that this part is done. So for this part, dp shows the number of ways that the GCD is x. When I'm here, so I know that these values are good. These values, dp's of these values are the real number of ways that GCD is that much. So it's just enough for me to have a for on all the multiples of x and find that in how many ways GCD is 2x. Those are bad. I should subtract them from dp of x. In how many ways GCD is 3x? Those are bad. I should subtract them. In how many ways GCD is 4x? And the point is that these dp's are really the values that GCD is y. Because y is greater than x, and I presume that I moved from the last one to the left one, and I use something similar to induction, and I'm just saying that the next ones are updated, and I know their current value now. I know what is the value of their, how many number of ways do I have for them to be the GCD. And for this one, x only is a common divisor, not the greatest ones. But I know that for the next one, in how many ways they are the greatest common divisor. So I will have a for on them, and I will subtract those values. And this way I can find the final answer. The problems are shared in the Telegram channel. And let me again send the address of the Telegram channel and the discussion. I will make a discussion right after the contest. I will make a discussion sub chat for them. I mean, I will send a message that below it you can send your questions and your messages and discuss further. And I will also update the descriptions of this video to add the links of all the problems. I probably also write a CF blog that I write the statement of the problems and a short summary of the solutions. And I think that's it. That's gonna be cover everything. Is the solution of this problem clear? If you are okay with that, please again use this emoji. So we could not cover this last problem, but we covered the first five things that we wanted to discuss. But we will definitely discuss this in the next episodes of this topic stream. As I said, this is going to be a weekly event each week. At the same time, we're gonna have it unless there's a contest or something at that time. In that case, we're gonna just move it. I'll set polls in the Telegram channel each time to ask you about the topic, what topic you want to cover, and what is the time if we wanted to change the time. So we will definitely discuss more problems on all these topics. And please give me your suggestions, guys. This is your live stream, so let's try to make it better together. This is for all of us, these live streams. I'm really enjoying doing this, and I hope that you are also enjoying watching this. So let's try to make anything we can to enjoy it even further and make it even better. So please tell me about your ideas, either in here, in YouTube, in the comments, or in Telegram, or in Codeforces, or in message me on Codeforces, or anywhere. Tell me about your ideas such that we can improve the next ones, and also mention all the flaws that we might have possibly had in this stream, such that we can maybe fix them in the next ones. If the quality of audio is not good, if the speed, if the pace that we were covering the problems was not good, if anything was not good, if the lighting was not good, just tell me and we will try to fix that for the next one. How to join Telegram, I send the address again. Awesome. Yes, okay, I will send the link of the 6th problem there as well. But we will cover them in the next ones. Awesome. I'm so happy if it helps you. I'm so happy if it helps you. If you want to support my work, I again appreciate it if you can like the video from here or subscribe to the channel. And also, I think one other thing that really can help is to comment below the video. So when the video is done, if you wanted to support, you can send comments below this video. But you do not have to do this. This is just something that if you wanted to support and make this stream bigger, you can do this, but you do not really have to do any of this. So I guess we're done. I'll try to answer all your questions in the comments below, or in the Telegram, or in Codeforces. So I guess I'll see you the next time. For either, I think there's a contest 2 days from now in Codeforces, and I'll see you then. Yes, it's in 2 days. Awesome. Thank you. So glad to hear that. Thank you very much. So see you in the next streams, guys. Don't forget to tell me about your opinion. See you guys. Bye.